when I asked you to watch the Khan Academy video and then to write about it in your notes. Does anybody know who Bob Ross is?
Yeah.
So I was kind of hoping for a little Bob Ross in this. You guys gave me number theory. You still got 100. Okay, but when I gave you a Bob Ross, it's because I wanted art from you. I love art like this, like roots. Plus the math. I have math up there too.
I just put the math.
I know. You guys are so indoctrinated to give math like
I
that
know
all
who
the
Bob
time.
Ross is. I've
That
never
when you
watched
actually do something fun like this, you completely forgot the fun part and you just did. But you got 100 still. I'm not going to give you
it.
100.
Oh crap! I didn't send you a screenshot.
So then you have no grade right now. But anyways, so I know that you're not used to my style of teaching because I do want the number crunching, but I also thinking about math in the picture and being creative, like with the Sierpinski triangles, and doing that kind of stuff, looking for patterns. So I just wanted to bring it up that Bob Ross style. Talking about roots. Roots. She was talking about roots, which was square roots is what we were talking about. Here we go on 2.1. 2.1. Perfect squares. What's the first perfect square you can think of? So we had 0, 1. What's the next one? 4, because you were thinking 2 times 2, right? 4. Keep going. What's the next one? 3 times 3. 4 times 4. Those are perfect squares. 5 times 5. 6 times 6. 7 times 7. Go all the way up to 12. Those are perfect squares. So a perfect square, perfect square, means that if I have 9, that would be a 3 by 3 square. It's perfect. The square root of 62 is a non-perfect square. We need to be able to estimate to 1 decimal place all the time for non-perfect squares so that we can order them with perfect squares and whole numbers and integers and all that good stuff. It's between 2 perfect squares. What's the first perfect square that comes before 62? 49. What's the perfect square that comes after 62? 64. So you're like, okay, I'm going to put it on top. This is going to be the square root of 49. This is the square root of 64. Those are 2 perfect squares, and I know the square root of 62 is in there. Do you think the square root of 62 is closer to 49 at the halfway mark or closer to 64? So I'm just going to put it over here then. That's about where it is. What is the square root of 49? That's where the number line goes down bottom. What you're trying to show goes on top. Your number line goes on bottom. What's the square root of 64? 8. What's halfway between 7 and 8? So these are like your markers to look at. To say, am I between 7 and 7.5? Am I between 7.5 and 8? And we're right before 8. So I would say that the square root of 62 is approximately, you don't put an equal sign. It's approximately, what would you say it's approximately? 7.8, because it's not going to be 8. It's not right before the 8, because you still got the square root of 63 in here. So I would back it off a little bit and say it's about 7.8. That allows you to be able to order on the number line when you have a rough idea of what a square root is. That's not perfect. Ordering on the number line. And so, one technique that you could do, what's a good strategy? Like you see these numbers, what's a good strategy to start trying to order something? Is there anything that pops out in your head? You're like, yeah, I would try this. Finding the answers to the square roots, definitely. Absolutely. So the thing about number lines is that when I put them on my number line, I always use the original. I can manipulate it, but I need to make sure that I use my original. So I can see the square root of 9 is what? That's 3. How about the square root of 13? So I don't have to make a number line like I did up top. I could just think of what's the perfect square before and after square root of 13? Square root of what? square root of 9, and which the one that comes after. And then I can see, okay, well, am I closer to the square root of 9 or am I closer to the square root of 16? This is 3, this is 4. I know I'm in between the whole numbers of 3 and 4, right? The square root of 9 is 3, the square root of 16 is 4. So I've narrowed it down into time and space between 3 and 4. I just need to know, am I closer to the halfway mark or am I closer to 9 or 16? How far away am I from 9? I'm 4 away. I just lightly put that there. How far away is 13 and 16? So when you see that the distance between the two, the numbers are really close, where do you think you're more near? The middle. So we're thinking about, let's see, 3.5 would be exactly the middle. Would I skew it a little bit? Why? Because it's not exactly 3 and 3 or 4 and 4, right? So I would say I'm a little bit more on the after 3.5. So I'd probably say 3.6. The square root of 9, I know is exactly at 3. Square root of 9. Negative 2.5, negative 1, negative 2, negative 3. So negative 2.5 would be right here. 3.6 for the square root of 13. So here's 3, a little bit after the halfway point. For the square root of 13, it's on the outside. The square root of 1 is 1, and then the negative is in front of it to make it a negative 1 answer. What would go above negative 2? That would be the negative square root of 4. When I do the square root of 4, I get 2, and then the negative is out front of it, making it a negative 2 answer. So can I see where the square root of negative 5 is going to be? Okay, so that takes care of that. We know the negative square root of 5 is right here after this. I get a little messy, so I'm just going to put negative square root of 5. Probably go back. And then we have one more.
1 and a third.
That's how I would look at it too. Change it to a mixed number, 1 and a third. And then I know I'm going 1 and a third more. Well, 2 lines gives me 3 pieces, so I could say about right here, 4/3. Always using your original. I have to take points off if you don't use your original number. I noticed that they don't actually have a set in here called a natural set. Natural numbers, they did not start with natural numbers. How did you naturally start counting?
1, 2, 3, 4.
Yay! Oh, I was so proud that you could count to 3. You didn't go 0, 1. No, nobody counts like that. Natural numbers is 1, 2, 3 to infinity. And beyond. So what is the whole set? What makes it a whole set? I know that the natural numbers are part of that 1, 2, 3. I know it has 1, 2, 3 to infinity in it, but it has something else. It's the 0. It adds 0. That makes it a whole set. It's adding 0. I know the whole numbers are in the integers because it's nestled inside of it right now. It's not separate like when you have irrational numbers. It's outside the set. It's within the integer set. The whole numbers are in the integers, so I know that I have 0, 1, 2, 3 to infinity. But that's the whole set. So what's been included in this set to make it the integers?
Yes.
I'm sorry, what? Negative numbers. So you have negative 1, negative 2, all the way to infinity. Hey, Hunter, this one's for you. The integers are in.
Now it's.
What's the root word in rational? What's a ratio? A fraction. And what is a fraction? It's also a decimal. So the root word in rational is a ratio. A ratio is a fraction, and a fraction is also a decimal. That's what the rational set has. It has all the integers in it, and it has fractions and decimals. So I'm going to say, okay, going from infinity, I have negative 2, and I'm going to put negative 1.5 for a fraction, 0, and then you can put your own in. I'm only putting 1 fraction and 1 decimal. So there's negative 1.5. Then I'll put 1, 2, 2.5, 3 to infinity. So you have rational numbers, and some things that we need to say about rational numbers. We see that we have, what kind of decimal is this? So we have terminating. So we had terminating. So that would be like 0.5. That's one kind of decimal. What other kind of decimals are there? Repeating decimals. So I could say like 0.3 repeating, 0.3333333 forever. And these all have to do with being rational. Terminating, repeating. What other kind of decimal is there?
The irrational ones are
The ones that go on forever. So
pi.
like pi.
Delicious.
So for these ones, it would be decimals that go on forever.
That's not on.
Decimals that go on forever. No pattern. Your non-perfect squares. So that would be like the square root of 3, the square root of 7, whatever. A non-perfect square. Those are the only kinds of irrational numbers. When you take rational and irrational number and you put them together, what is it called? Been working on it just about your whole life.
Real numbers.
Those are the real numbers. And you say to yourself, well, are there any other kind? Yes, we just talked about them. Imaginary numbers. Okay, so this is your real number set. Real numbers. All right. So in words, real numbers consist of rational and irrational numbers. In words, real numbers consist of rational and irrational numbers. So I'm going to do it right now. So the natural set, you just do 2 lines and then you make your n. 2 lines and then I'm going to make my n. So we've got the naturals. This is part of the whole set. Ah! Natural, wholes, what else would 1 be a part of? That would be part of the integers. And it's also a part of the rationals. Let's see. 23. Where does 20? All right, so it's the same thing again. 23 would also be in the naturals to start. Integers. Rationals. And the reals. How about the square root of 2? Where does the square root of 2 belong? Is it a perfect square? So where does it go? Irrational. So that would be I. Anything else? Yes, it's a part of the real number set. They're all part of the real numbers. What about 32 and 45 hundredths? Where's the very first place that you would see 32 and 45 hundredths? Rationals is the first place that you see it. And yes, it's a part of the reals. What about 5/6? Where's the very first place you see that? Again, that would be rationals. And yes, it's a real number. -4 and 3/8. Where's the very first place that you see -4 and 3/8?
Rational because it's correct.
Well, most people would say. But if I look at integers, do I see any fractions and decimals in the integers? No. Most people would say integers because they see the negative. But there's no decimals and fractions. The first place I see a decimal and a negative would be in rationals.
I said rational.
I know, but I'm just saying what most people would have said because they see that negative.
Well, not most people.
All right, so we have
That is weird.
rationals, and of course it's real. -8, where's the very first place you see -8s? Integers, and then it continues on to the rationals, and it's a real number. This is how you're always going to see it right here anyways. You don't have to worry about the notation. I always make boxes, and you put an X for where it does belong. Okay, why don't you go ahead and try these 4 right now. Alrighty then. So the square root of 24 is not a perfect square. That would make it irrational. And I'm going to go like this because I know they're all real numbers. Now this equals 10. You got to make sure you reduce it if it can. So I'm looking for 10. That means whole numbers, integers, rational and real. Is 81 a perfect square? Yeah, so what's the negative square root of 81? That's right, it's 9, but I got to carry the negative along in front of it, making it a negative 9. So that would be integers, rational, and real. All right, negative 1.5. The first time I see a negative decimal is going to be rationals and real. All right, so looking at, again, you know, I like the picture. So when I'm thinking about the square root of 4, I know that it has an area of 4. It's a 2 by 2 that has this 4 blocks here. That's an area of 4. So I would say the square root of 4 can be broken down into the square root of 2 times 2, which is just 2 for a final answer. So that's the picture to it. That's what's actually going on in the picture. The square root of 16 would mean there'd have to be 16 squares. So that's a 4 by 4. What does the square root of 7 look like then? What's the perfect squares before and after the square root of 7? Square root of 4 is 2, and the square root of 9. So yes, we're between the whole numbers of 2 and 3 then. So that's why the picture looks like this. It's a 3 by 3, but not everything's colored in the 3 by 3. It also has a 2 by 2 in it. The 2 by 2 is completely colored in, but the 3 by 3 has some missing from it because it's not perfect. So there's my number line to show that the square root of 7 is between the square root of 4 and 9, as you said, the whole numbers of 2 and 3. I would put the square root of 7 about right here. So it's about 2.8, 2.7. So that's perfect squares, non-perfect squares. What about this one? I wonder what this. Did you know that square roots are understood to have a 2 out front of here, but we never put the 2 there? The index number, it's called the index. Anything higher than a 2, you have to put a number in there. So it's assumed that everybody knows that there is an index number of 2, but when you go to 3, what does that mean for the picture then? 3-dimensional. No, it's 3-dimensional. Okay, a square is 2-dimensional. A cube root is going to be 3-dimensional. You don't have to draw all of this if you don't want to. It's fine. Okay, so you're talking about 4 by 4 on 3 of the sides. This side, the top, and then going out back that way. That's what gives it the 3 dimensions. You take 2 dimensions and you draw it out. Alrighty then. So we're going to do one more. We're going to stop here, and then on Thursday, we're going to talk about properties. So make sure that you watch the video or join class live when we go over the properties. We're going to finish up with real numbers today. And we are just trying to compare them. So the square root of 10, approximately, how much is the square root of 10? If I think about the square root of 9, does the square root of 10 come before or after the square root of 9? 9. It's after it. So I know that this is 3, and this could be like 3.1. So boom, I can already see that 5 is larger. We're just comparing them. The square root of 99 is next to which perfect square? So the square root of 100 equals what? 10. So what would the square root of 99 be?
9.9.
Like 9.9. So I can see that that's the larger one. All right. The square root of 8 is approximately what? Like, what's next to the square root of 8? So square root of 9 over 2. How much is the square root of 9? 3. I'm going to leave it at that for a second. If I have to get more specific and get closer, I'm going to. But I'm going to see if I can compare 3 halves and see if the other numbers just so far away from that that I don't need to go any deeper on the square root of 8. The square root of 13 is next to which perfect square?
15.
So it's before the square root of 16. So this is about, so you could say 3.6. So it's almost a whole number. Not quite a whole number. It still needs, so let's just say it was a whole number. Say it was 4. What's 4 over 4? 1. How much is this one? 1.5. So, I mean, I didn't need to get real specific on this. I could have. I can see that this is more than 1. This is not quite 1. So I would say the one that is more than 1 is the greater one. Okay, next one. Put the following numbers in order. Be careful with directions all the time. Least to greatest. We're between the numbers 4 and 5. Go ahead and try to put those numbers on your number line. So whereabouts did you guys, I'm sure you found 4.5. Whereabouts did you put the square root of 22? Do you think it's leaning towards 16 or the square root of 25? Okay, so now you got to figure out where do you want to put it in here. Square root of 25. What would be the square root that's exactly halfway between these two? Yep, very good. So I see you're doing the same thing I was doing. I was thinking, well, how many are in between there? And there are 9 in between there. So it's about the square root of 20, just roughly the halfway mark. So I would say that 22 is really more, here's the halfway mark between these. I would bet that it's a little bit more leaning on this side. Square root of 22. And then we have pi plus 1. They went to dinner and brought a guest. Pi plus 1. What?
I put that really close to these.
Okay. How did you know that it was close to 4?
Because it's 3.14 plus 1, so that would be 4.14.
Very good. So about 4.14. Okay, one more. Ordering the last ones. And we'll get started on your homework. You've already got your notes in. And just put a mark after 9 and put pi squared. Okay, so your homework worksheet is this, 2.1. And I just want to point out that down here at the end, for number 13, students for some reason always skip this one, but you need to order the numbers that are in the chart right here, least to greatest. This is what it means. You're going to use these numbers in the chart to order least to greatest.